Hey, this is Paul with LSP Data. In this video, I wanted to show you how we're doing a lot of image processing, leveraging LLMs. So I know everyone's trying to leverage AI, quote unquote, right? So I know people's use cases typically grab an image, upload it to ChatGPT, and get descriptions and whatnot. But I'm going to walk you through how you can leverage open source LLMs, and that way you get an idea. It allows you to process images, and it'll allow you to describe images and extract objects from those images as well. So again, this is how we're, the type of technology that we're leveraging with Virtual Drive for Dollars. Here's a few examples. So in this case, obviously our platform is to identify distressed properties, right? So we'll walk through an example of how we're leveraging these LLMs, and so that way it benefits our customers, right? And if you're doing any projects or you're processing images, etc., this may help you as well. So yeah, let's get into it. First, I've made it a little bit easier for you to search for this specific LLMs, and I'll include that in the description as well. But if we click on this, right, there's different LLMs that are available for download using Hugging Face. So two of them that we're going to focus on is this Facebook one and this Salesforce ones. And I'll touch on this real quick. So the Salesforce model allows us to process images, and basically I take a picture of you, you're drinking a cup of coffee, right? Or a cup of water. The model will process that image and it'll output a description of what's happening, right? So in this case, it'll say a man is drinking a cup of water or a cup of coffee, right? And that's very useful since a lot of times the images that we're processing have to do with distressed properties, right? But it could be around high grass, it could be about property that is not maintained, whatever the condition may be. Whereas this Facebook model here extracts specific objects. So again, instead of describing what the image is, it'll extract the information about a person is an object, a cup is an object, glasses are an object, etc. So for my use case, since we're processing hundreds if not thousands of images daily, this makes it a lot easier and it reduces manual work, because in the past, someone manually needed to review each of those images, right, that we're describing here. So it's allowed us to automate a lot of that process. And again, I'll give you a quick example here in a second. So let's say this is the raw images that we would process, right? So this is how they would look like. And obviously, this would be good for use case, right, for ours. The other bits would be this one, which is the image that we saw a second ago, right? So if we notice the file names here, we can jump into the sort of the output of the script that I'm running. So this is a pretty good example of that, right? And on this specific image, I believe it ended with 74. Let's look at it real quick. It's 674. So it'll say a driveway with gate and bushes, right? So the Salesforce model will process a lot of that, and it'll give us the descriptions I mentioned, and a lot of those will identify the objects, right? So as you saw from some of those images, there was a car parked in front of the house, right? So that's the first one that it processed, which is this. Pretty accurate, right? So again, we're doing this on hundreds of images, and obviously there's different cities and whatnot. So this has definitely helped to make that task a lot easier. Some of them, there is a high rate of false positives, right? Meaning that the model doesn't get it right all the time. But as you can see, there is a bit of a confidence level here. So basically one would be that is high confidence, right? So for our use case, so for example, in this instance, truck, car, pretty high confidence. As you saw, there's no person, right? So again, sometimes it doesn't get it right. but for us, we have specific sort of criteria. So in this instance, we definitely want to exclude any instances in which there's faces of a person, right? So if you ever, if you're an existing customer or you are thinking about signing up for a product or service, though there's never going to be a picture of a person, right? And part of that is just to protect privacy, but everything else is relevant to the driving for dollars use case, which is what we're interested in, right? So again, just wanted to show you how we're leveraging those two models, and I'll show you an example of the script just so you can see how it looks like. So this would be, basically using these libraries, this Python libraries, Shuttle. We're looking into that specific path. These are the models that we're leveraging, right? Blip processor, and also the this Facebook one as well. So, and again, we're only interested in image files. A lot of the files that we receive may be videos, and at the moment we're not processing videos. But ultimately, as we scroll down, here's the bit that I wanted to show you. So we have specific thresholds again, right? If there's instances in which there is a person, right? And over the years, we've sort of perfected our criteria here. So it's as simple as adding specific exclusions that don't allow for unwanted images to end up on the website, right? So it makes it a lot easier to process. And again, in the past, this saved us from an individual having to go and manually review them. So does the model get them right all the time? It doesn't, but it definitely saves us a lot of times. And yeah, it's a really good use case. So if you want to test any of those, I may include the Python script if you have any questions, but I wanted to show you a little bit behind the scenes of how we're processing a lot of the images that end up in our driving for dollars. And that way, as we get better, as we leverage better technology, you'll get additional images on the page, and that's what we're striving for, right? So, but I figure if any of you are using any kind of images, or if you're having to upload images to ChatGPT, specifically pictures that may be more sensitive, right? You don't need to do that. These models can run locally on your computer, right? So it makes it a lot easier, even from that privacy kind of standpoint, because the models are all hosted locally. And again, based on your criteria, they'll improve it every once in a while. So just check if there's any new updated ones to play with. Python has libraries for the transformers as well, so it makes it a lot easier to use those models, right? And obviously, if you have any questions on the implementation bit, you can always ask ChatGPT or Claude, which are really good at, you can feed it this image, give it a use case, right? Maybe point it to the path where your images are at, and ask it to generate a CSV or text file that may look similar to the one I showed you here, right? So for me, it was 1, output the description of the image, and 2, output the objects identified, and then based on that, create a criteria that manually deletes the images whenever they're not relevant to our use case. And ultimately, it'll generate that CSV. What ends up making it to the website is already excluded, and it makes it easier again to show you relevant images that are relevant to virtual driving for dollars. So I'll leave it at that. And again, if you have any questions, put it down below, and thank you.